Hey everyone, welcome back to the lab. In this video, we're going to be benchmarking F HTML DSLs for deeply nested pages. In this one, we're going to be comparing Falco.Markup, Giraffe.ViewEngine, and Feliz.ViewEngine, which are a few of the more popular HTML DSLs in F#. So last week, we benchmarked these F# HTML DSLs for rendering long HTML pages. And this is useful if you're building pages with very large lists or tables, but this is actually a relatively rare occurrence in real life, as you'll usually be splitting up very large kind of lists of items, either with pagination, or you might even have kind of like dynamic node re-rendering on your page, especially if you're doing kind of like a super long kind of infinite scroll kind of guy, which, let's be honest, is really just pagination with a few extra steps. But the point is, you're often not going to be rendering like 5,000 items in a giant list. Instead, you'd be like, I don't know, 100 items with 50 pages or something like that. But this doesn't mean that like a lot of our pages are just going to be like very small. A more common paradigm, if we think about it and how we actually build, web pages, is we're probably going to be rendering deeply nested pages. And so if we kind of think of like a sufficiently mature or complex web page, it's typically going to consist of several different components. And the way that I think of these is kind of like as interactive islands in this kind of server-side rendered paradigm, which I talk about more in this post. And so you can kind of think of like, most pages are basically just static, and then on it we might have a few components that like need to change. This might be like a few widgets, maybe there's like a main content section, maybe there's like a sidebar, a nav bar. And so the page itself is actually rather short, but then we have these like few interactive islands that might be very complex and deeply nested in order to get their like styling right, to get their functionality right, and things like that. And so mostly these pages kind of take on the form of, this is often kind of described as like a tree, where you have the main trunk is very large and then it kind of branches off into these other branches, or also icicles are a way that's often described as. But basically a few different main branches that like kind of go on for a long tail of deeply nesting. And so we previously deeply nested page benchmarks, and these revealed severe perf issues with raw string HTML rendering when compared to HTML DSLs, and we found like a difference of about 1,700 times at scale. And so in this post, what we're going to be doing is running these HTML DSLs through the same kind of workload to understand how they stack up. All right, so let's start off with the benchmark setup. And this is basically what we're doing here. So we basically just got like kind of a wrapper, empty HTML page. And then what we're going to be doing is we're going to be creating divs that are nested inside of them. Each div is going to have like just a piece of text in it that's going to say like, oh, I'm item 1, I'm item 2. And then it's just going to contain the next div in the series. And so we're going to be doing this from 10 to 5,000 items for each of these. And we're going to be running benchmark.net as kind of the benchmark runner, so that can aggregate stats and stuff like that. And then we're going to be running all of this on a free Replit instance, just because it's easy, it's free, easy for me to share with you, so you can run it yourself. And this will be available here at this Replit instance linked in this post. And so here's all the code if you want to just look at it and run it yourself. Okay, now let's talk about the results. So here is all the results that I got kind of graphed, and we can see that, Falco.Markup is in blue, Giraffe.ViewEngine is red, and Feliz.ViewEngine is yellow. And so Falco.Markup and Giraffe.ViewEngine are basically the same. There's a little bit of difference here. We see that the red line is a little bit higher than Falco.Markup, and that's kind of what we see is Falco.Markup and Giraffe.ViewEngine are very same throughout all the workloads, with Falco.Markup coming out at less than 10%. Like it's like 1 to 10% depending on the size faster, but we can basically assume they're about the same. And then Feliz.ViewEngine is just slower throughout by about 3x. Now the absolute difference here is in the tenths of milliseconds, and so like that's like very small for HTML rendering purposes. We can almost assume it's like just margin of error kind of thing. So basically the same, but definitely Feliz.ViewEngine slower. And the difference is here, as like on the high end is about 10-ish milliseconds, and on the low end we are like 1 to 5 milliseconds. All right, in this section we'll just talk about the detailed results. So here are all of the results. I put it in a little table for everyone to see. We've got Falco.Markup here, we got Giraffe.ViewEngine here, we got Feliz.ViewEngine here. And then because Falco and Giraffe are so close, I just made a little column to compare them to kind of see what the differences are. And so we can see that, even at 5,000, Falco.Markup, Giraffe.ViewEngine are like nanoseconds apart. So they're basically the same. So it's basically anywhere from like 3 to 10% faster. And then we see in this one case, Giraffe.ViewEngine is a little bit better at 1%, but we can kind of see this as like margin of error. Feliz.ViewEngine, here we can see it, that's about 10 plus milliseconds slower, which is about like 3x slower than Falco or Giraffe. But, when we get to the smaller ones, it's like a few milliseconds, which, in HTML rendering terms, probably not a big deal. So that's the major results. I do have all of the screenshots for each of the other ones from benchmark.net here, if you want to take a look at those. And that'll be linked in the blog post below. All right, so overall, Giraffe and Falco perform very well and are pretty easy to work with, so I would definitely recommend those for your HTML DSL rendering needs. Feliz.ViewEngine is still pretty fast, but I think coupling its like relative slowness with its kind of clunky API, like it's definitely built for React. They definitely built with this kind of like super nested children thing, and it's kind of just clunky to put them all together versus you look at Giraffe and Falco, everything's just a list, super easy to compose, super easy to reason about. So I didn't really like that. And then Feliz hasn't been updated in like 2 years. So like all of this together, like while I think it's a fine rendering engine, I just feel like it's probably just not as good as the other ones, which don't have these problems. But this is just from my perspective. Like I said, I think it's probably fine to use if you really want to. Last thing is, if you have any suggestions for other HTML DSLs you'd like benchmarked like this, please send them my way. Every single time I publish these benchmarks, a bunch of people come back to me with other DSLs or rendering paradigms that they're using in production, which I haven't heard of yet. So if you want to see these, let me know, because otherwise I probably won't know about them. Now, if you like this post, you might also like comparing these same F# HTML DSLs for rendering long web pages. I think both of these together give you a better idea of how these will actually perform for most web pages overall. You might also be interested in simple interactive islands with F# and HTMX, kind of the philosophy of building with F# and HTMX, why I think it's good, and some kind of patterns that I think work really well for this that might be a little bit different than what you're used to if you're in a spa. And then if you're just into HTMX, this post goes more into like the philosophy of why I think HTMX is like a game changer for building web apps faster, especially ones that are server-side rendered but still very modern, and why I've personally switched away from doing kind of like the dual monolith spa backend to literally just one monolith that does everything. So that's it for this post. Thanks for watching, and I'll see you in the next one.